The Great Debate and More Sightings. An Intramercurial Planet? Anonymous, Nature, Volume 14, page 418, 1876. At the sitting of the Paris Academy of Sciences on the 28th ultimo, Leverrier announced that he had received a letter from Professor Rudolf Wolff of Zurich, in which it was stated that 3 observers situated in 3 different places had witnessed, on April 4th, the passage of a round spot over the sun's disk. The 3 localities were, in Germany, near Munster, Greece, Athens, in Switzerland, Zurich. The date is subsequent to the observation of Dr. Lescarbault by 6,219 days, which figure is the product of 148 into 42.02, printed 40.02 in the institute whence this notice is taken, and it may be conjectured that, if the object were a planet, it had made this number of revolutions of 42.02 days. Such a body would have a mean distance from the Sun equal to 0.2365 of the Earth's mean distance, with a maximum elongation in a nearly circular orbit of about 13.5 degrees, the period of revolution being almost precisely half that of Mercury. We await details of the observations before examining how far the date 1876, April 4th, can be made to agree with similar ones already upon record, supposing all refer to a single body revolving under the conditions named. The Intramercurial Planet or Planets. J.R. Hind, Nature, Volume 14, pages 469 through 470, 1876. The question of the existence of one or more planetary bodies revolving within the orbit of Mercury is again revived by Weber's observation of a round black spot just within the Sun's eastern limb, on the afternoon of April 4th in the present year, which had not been visible on the same morning, and early on the following day had disappeared. The position at 2 3/4 minutes only from this limb is one where an ordinary spot would not be expected to exhibit a circular outline, and a round black disk, in such a position more especially, must instantly attract the attention of a practiced observer. On April 4th, clouds unfortunately prevented lengthened observation, and in Weber's notice there is no reference to any perceptible motion during the short time the spot could be watched. This observation resembles others already upon record, made by persons equally worthy of credit, which it is hardly possible to explain except on the hypothesis that one or more planetary bodies exist with mean distance less than Mercury. The rate of motion where motion has been detected by the most reliable observers, not being consistent with greater distance from the Sun. While it is certain that comets with perihelia within the Earth's orbit have transited the solar disk, and notwithstanding such transits may have been more frequent than is generally supposed, the appearance of the spots now in question seems, at least in several of the best authenticated cases, to negative any idea of their being due to the passage of comets across the Sun, near their nodes. At the same time, there are several instances where the form of the spots would perhaps accord better with the assumption of a cometary transit, unless we can admit that the deviation from circular contour is attributable to an optical cause. It may be remembered that the attention of astronomers was first seriously directed to the possible existence of a planet or planets interior to the orbit of Mercury by Leverrier's announcement that the motion of the perihelion of this planet was not explained by known causes of perturbation, but that an excess of 38 seconds in the century must be admitted beyond the value derived from theory, to produce an agreement between calculation and observation in the discussion of the long series of observed transits across the Sun's disk. The unexplained motion of the line of apsides might, as Leverrier remarked, be due to the existence of a single interior planet of a mass which would depend upon its mean distance. With a distance of 0.17, period of revolution 25.6 days, the mass would be precisely equal to that of Mercury, and it would vary inversely with the distance. Or it might be due to a group of small planets circulating within the orbit of Mercury. Having before us the whole of the recorded observations of the presence of suspicious spots upon the Sun's disk, we shall soon discover that they hardly admit of explanation on the hypothesis of a single planet, even if we assume a small inclination of the orbit of this planet to the ecliptic, a condition which, while it would greatly extend the transit limits, must at the same time render the transit so frequent that it is in a high degree improbable that the planet could have so long escaped certain detection. Some few of the observations, as just remarked, we may perhaps refer to comets in transit. It remains to endeavor to ascertain from observations not thus explained what period or periods will best represent them, with the view to being warned of the probable times of future transits. This subject has engaged the attention of Leverrier during the last few weeks, or since he became cognizant of Weber's observation last April, the notification of which was long delayed. It appears that the observations of Stark and Steinhebel, 1820, February 12th, Lescarbault, 1859, March 26th, and that of Weber may refer to the same planetary body if the revolution be supposed 28.077 days, this being the sidereal revolution with respect to the node. The synodical period would be 30.33 days. The corresponding mean distance from the Sun is 0.18 astronomical units, and the maximum elongation 10.5 degrees. And if Lescarbault's observation affords any approximation to the position of the line of nodes would pass across the Sun's disk, and for this reason Leverrier has directed attention to the importance of a close watch upon the same during these days, such watch, if possible, to extend to distant meridians, so as to ensure pretty continuous observation through the 48 hours, Paris time. He has already advised American observatories through Professor Henry, Secretary of the Smithsonian Institution, and it is to be hoped the chance of making an important discovery at this time may be made known to observers in the East. It will be seen that the aid of the telegraph is indispensable in order to secure complete evidence of the existence or non-existence of the hypothetical planet this autumn. Other observations may be reconciled with a period of similar length, but the planet to which they may be supposed to refer cannot be identical with the above. Thus, if Mr. Lummis's sketch of the path of the small round black spot, which he remarked upon the Sun at Manchester on the morning of March 20th, 1862, is reliable in the hurried and otherwise disadvantageous circumstances under which it was made, the ascending node was almost diametrically opposite to that of Lescarbault's planet, elements which have been attributed to M. Valls and Radau, and exhibiting a near agreement in the position of the line of nodes, being certainly erroneous. Again, one of the most interesting observations bearing upon the existence of an intramercurial planet is that made about the end of June or beginning of July, 1847, in this country, which can hardly be supposed to refer to either of the objects seen by Lescarbault and Lummis respectively. The exact date of this observation is unfortunately lost beyond recovery. Mr. B. Scott, the city chamberlain, observing the Sun's disk near London, a short time before sunset late in June or on one of the first days in July, remarked upon it a perfectly circular black disk, and was so confident of the unusual character of the spot that he was on the point of making known his observation through one of the London daily journals on the evening of the same day, when unfortunately an astronomical friend, under the impression that an ordinary spot had been observed, dissuaded Mr. Scott from so doing. It thus happened that the matter was dropped until the announcement in 1860 of Lescarbault's observation on March 26th in the preceding year, when Mr. Scott, in a communication addressed to the Times, drew attention to his experience in the summer of 1847. It was then discovered that he had not been the only observer of the strange object. Mr. Ray, the well-known optician, then resident at Whitby, had remarked a small circular black spot upon the Sun late one afternoon at the end of June or early in July, though he also had, in 1860, lost the exact date. Both these gentlemen have furnished the writer with every other particular of their observations. That they refer to the same object can hardly be doubted. Mr. Ray had it under observation for 40 minutes, when the Sun sank into a bank of cloud and was not again visible that day. In this interval, the spot appeared to have moved about 5 minutes of arc, and when last perceived it was so near the western limb of the Sun that Mr. Ray believes if the cloud had not interfered, in about 10 minutes he would have witnessed the egress. This circular spot, the diameter of which he judged to be about 6 seconds of arc, was not visible early on the following morning, though other spots of ordinary form which were present on the disk remained nearly unchanged. Mr. Scott was observing with a refractor of about 4.5 inches aperture, Mr. Ray with a fine 6 feet Newtonian reflector of equal aperture, which he was employing at the time in a study of the varying aspect of the solar spots. Notwithstanding the unfortunate loss of the date of these observations, such particulars as are available are still of value as certifying the existence of such planets in transit. There is no observation of the kind resting upon more excellent authority. A letter from Professor Heiss, of Münster, the author of the Atlas Celestis Nova, received while closing these remarks, gives full details respecting Weber's observation. The spot was intensely black, perfectly round, and smaller than the planet Mercury in transit. Professor Heiss expresses the utmost confidence in this observation by his friend, who has long been accustomed to examine the solar disk. An intramercurial planet. F.A.R. Russell, Nature, Volume 14, page 505, 1876. The discussion as to the existence of a planet within the orbit of Mercury leads me to communicate an observation made many years ago, which I believe nothing but the existence of an unknown planet between us and the Sun can explain. On Sunday, January 29th, 1860, the Sun rose in a fog in London, so that he could be steadily looked at as if through a dark glass. Soon after 8 o'clock, a perfectly round black object was seen by 4 persons, including myself, clearly defined upon the lower half, according to my recollection, of the Sun's disk. It passed slowly across his face and made its egress at about 9:30 a.m. In apparent size, it was equal to the representations I have seen of Mercury in transit. The Intramercurial Planet Question. Anonymous. Nature, Volume 14, page 533, 1876. Leverrier made a further communication to the Paris Academy on the 2nd instant with reference to this subject. Having collected in his previous communications, chiefly from the original authorities, such observations as could be supposed to bear upon it in any way, he finally selects for discussion those only which, in addition to the roundness and blackness of the spots, have distinct mention of sensible change of position upon the Sun's disk on the day of observation. There are 10 cases under this head in the months of January, February, March, May, and June, or possibly beginning of July and October. Leverrier remarks that it is inadmissible that a body projected upon the Sun on February 12th, which is the date of the observation by Steinhebel mentioned in the correspondence between Olbers and Bessel, could repass at the end of March or beginning of October, that is, when arriving in the line of nodes of the objects seen by Lescarbault and Lummis. This could only happen if the first body moved in an orbit very little inclined to the ecliptic, but in this case the necessary frequency of the transits must have led to its being more often observed. For the present, therefore, he confines himself to treating 5 observations in October and March, where motion like that of a planet in transit are recorded. His data stand thus. None of the residuals exceeding a half-day's motion, Leverrier thinks it permissible to infer that the 5 observations appertain to the transits of the same body. With the above motion, the period of revolution is 33.0225 days, in the semi-axis major 0.201. The existence of an intramercurial body announced by theory being, according to Leverrier, beyond doubt. In conclusion, he states that he is now occupied in determining the epochs of the next following transits over the Sun's disk. Supposed discovery of Vulcan. Lewis Swift, Observatory, Issue 2, page 161 through 162, 1878. During the total phase of the late solar eclipse, as observed at Denver, Colorado, I had a view of a celestial object not down in Argelander's charts, which, to my mind, without any doubt, is the long-sought Vulcan. It was enfilled with a star of the same magnitude, probably Theta Cancri. As soon as totality was over, I recorded in my notebook the following. Saw 2 stars, about 3 degrees southwest of Sun, apparently of the 5th magnitude, some 12 minutes apart, pointing towards Sun. Both red. I immediately acquainted Professor Hoff, formerly director of the Dudley Observatory, and my 2 assistants of the discovery, and, as soon as possible on the same evening, Mr. Burnham, the celebrated double-star observer, and many others. None of them knew of any star in that position answering the description. On my way home, the thought occurred to me that the distance between them was about equal, perhaps a little greater than half that between Mizar and Alcor. On arriving at home, I found Webb gives their distance as 11.5 minutes, which would make the distance between Theta Cancri and the new object some 6 minutes or 7 minutes instead of 12, as estimated hastily and roughly, of course, at the time. The next morning I learned by telegraph that Professor Watson at Separation, Wyoming Territory, saw a star 2.5 degrees southwest of the Sun and of 4.5 magnitude, not down in any chart. The 2 observations are therefore confirmatory each of the other. As totality commenced some 4 minutes earlier with him than with me, of course he antedates me by that amount. Telescope 4.5-inch aperture, comet eyepiece, power 25, field 1.5 degrees, periscopic, and very superior. Stellar objects seen during the eclipse of 1869. J.R. Hind, Nature, Volume 18, pages 663 through 664, 1878. It will be remembered by the reader who has interested himself in the published reports of observations of recent total eclipses of the sun that during the totality of August 7, 1869, at a point in Iowa called St. Paul's Junction, several observers attached to a party organized by Mr. W.S. Gilman of New York remarked below the sun what they termed a little brilliant, and that one of the number using a small telescope reported having seen just before the sun disappeared and as he came out again a minute crescent, in a similar direction from the moon. Commodore Sands, then superintendent of the Naval Observatory, Washington, expressed his regret that these objects should not have been seen by Mr. Gilman himself, who had experience of the use of the telescope and was using a larger instrument than the others who had optical aid, but his plan of operations did not permit of it. The facts are thus stated. A few moments after the corona formed, a small but exceedingly bright point, like a star, was noted independently by 4 of the party, 2 of whom it is mentioned were observing without telescopes. It appeared near the limits of the corona, below the moon's disk, and with one exception the observers located it a little to the right of an anvil-shaped prominence, or at about 230 degrees from the north point, reckoning by the east, and it is added that each of the observers felt quite positive that what he saw was truly a star. With respect to the small crescent, Mr. Gilman reports that about half a minute preceding totality another member of the party, Mr. Vincent, came to him exclaiming that he saw a miniature crescent-shaped star under the moon, and asking him to verify the observation, but, interested in his own work, he did not at the moment do so. On Mr. Vincent returning more urgent than ever, Mr. Gilman says he did look in a hurried manner, but saw nothing in the few seconds he gave to the search. He afterwards states, however, that he does not think he looked so far away from the moon as the crescent was located in a drawing made immediately after the eclipse by Mr. Vincent. In this drawing it was placed at 1½ times the moon's diameter from its limb, and to the left of a perpendicular down to the horizon. Mr. Gilman adds he could not connect the crescent with the small star of the other observers. Indeed, Mr. Vincent estimated the object seen by him at 3 times as far removed from the moon's limb as the small star, which would assign for the latter a distance of about ½ degree, corresponding very well to the expression used by the 4 observers who noted it, that it was near the limits of the corona. Dr. B. A. Gould, now director of the observatory at Cordoba, who observed this eclipse at a different station, gave some attention to a search for any object near the sun which might be an intramercurial planet, and he states he saw the star Pi Cancri, but did not meet with any other stellar body. This star being at the time in a similar direction from the moon's center to the little brilliant of the Iowa observers, there has been a pretty general opinion that it was the object remarked by them, and, in conversation with Dr. Gould several years since, I found him tolerably well satisfied that he had thus sufficiently explained their observations. But the discovery, or rather discoveries, of Professor Watson lend a new interest to them, and a more strict examination of the circumstances may not be out of place here. The position of St. Paul's Junction is stated to be in latitude 42 degrees 47 minutes 30 seconds north, and the longitude 19 degrees 5 minutes 45 seconds west of Washington. The totality was observed to commence at 5 hours 48 minutes 4.6 seconds, ending at 5 hours 51 minutes 34 seconds, mean time, at Washington, so that the middle occurred at 10 hours 58 minutes 22 seconds, mean time, at Greenwich, which agrees exactly with a calculation made with the nautical almanac elements. We will assume 10 hours 59 minutes Greenwich Mean Time as the time to which the observations of the brilliant point apply. Correcting the moon's place for the effect of parallax, we will find her apparent position at this time to be in right ascension 9 hours 11 minutes 26.7 seconds, in north declination 16 degrees 13 minutes 58 seconds. Her augmented semi-diameter was 16 minutes 37 seconds. We must assume that both star-like object and crescent were on an angle of 230 degrees, the latter 1½ times the moon's diameter from her limb, and the former at 1/3 of this distance, whence, referring to the moon's center, we have, for the crescent, The former was therefore 28 minutes and the latter 56 minutes south of the ecliptic. Now, with regard to the star, the presence of which has been supposed to explain the observation of the 4 observers who noted the little brilliant, there has been some slight confusion. In a note inserted in the last annual report of the Royal Astronomical Society, it is stated that the object seen has been satisfactorily identified as the star Pi 1 Cancri, which is assuredly a mistake. Pi 1, according to Argelander, is only a 7th magnitude, which is hardly to be glimpsed with the most acute sight in the darkest winter sky. For Pi 1, no doubt we must read Pi 2 or 82 Cancri. But this star also is of a degree of brightness wholly insufficient to allow it of being possible to discern it at all so near the sun's place without some optical aid in the still illuminated sky ground, much less to be caught up as a brilliant point of light with the naked eye. The Durchmusterung estimate is 5.8 magnitude, which is confirmed by the careful estimations of the second Radcliffe catalog, where we find it rated 5.9 magnitude, or in round magnitudes, a 6th. It should be mentioned that the apparent place of 82 Cancri was in right ascension 9 hours, 7 minutes, 59.5 seconds, declination 15 degrees, 28 minutes, 56 seconds, agreeing nearly with that we have found for the minute crescent, but 33 minutes from the small star. It appears probable, in view of Professor Watson's discovery, that Dr. Gould may have mistaken an intramercurial planet for Pi 2 Cancri, and if the statements of the 4 observers at St. Paul's Junction, one of them, by the way, a lady, are accepted, it can hardly be doubted that they were also attracted by an unknown object, since in that part of the sky there is no star which could be visible as they describe it. It is significant that Regulus, upwards of 12 degrees from the sun's place, was only noticed as a glimpse star at St. Paul's Junction.